look into the fluvial geomorphology. Fluvial geomorphology, which is hello. So we are to look into the fluvial geomorphology. So the first one, we are to look into the groundwater and hydrosphere, the water found on the surface of the earth and that of the water found underground water. So we'll first get to the groundwater and then the hydrosphere. Under this, we shall look into how water got into the earth and what type of or kind of water found on the surface of the earth. So we are saying that groundwater is one of the most important and widely available resources. Yet people's perception of the subsurface environment from which it comes are often unclear and incorrect. This is because groundwater environment is largely hidden from view except in caves and mines. And the impression people gain from these surface opening are misleading. So people think we don't have any water found on the surface water under the subsurface, but there are water content found within the earth. So we will look into groundwater and hydrosphere as we. So we are saying that when you take the percentage of water content on the surface, we have about 70% of water found on the surface of the earth. Samuel Kwesi, off your video. Yeah. Off your video. And mute your mic too. Okay, so we'll be doing. So as we know from the beginning, 70% total of the earth is covered with water. And the lithosphere or the solid aspects under it too, we have water. So any water found under the surface of the earth is known as groundwater. And it's found in everywhere as far as the earth is concerned. So we come to geomorphic importance of units of your video so that we can have good interaction, and mute your mic. Units, mute your mic. Good. Geomorphic importance of groundwater. First importance. Geomorphic importance of groundwater. One, we are saying that water is a dissolving agent, or it can dissolve some of the rocks which can enrich our soil for agricultural purposes. And we also say that groundwater equalize the stream flow. Now, the groundwater, through seepage, groundwater can come to the atmosphere and water and increase the volume of water or equalize the volume of water in the stream. So, say much of the water that flows in river is not direct runoff from rain and snow melt. Rather, large percentage of precipitation soak into the ground and then move slowly under the surface to stream channels. So if we have a stream like this and we have underground water, I would say underground, but the book says groundwater, and there is crack, this reservoir of the water will seep into a stream, which will increase the amount of water found in the stream. Are you there? So that is the water, groundwater, increasing the or equalizing the stream flow. We are also saying that groundwater is thus from a storage that sustains stream during a period when the rain does not flow. You know, the main source of streams, the main source of water to streams is rainfall. How about the dry season? At the dry season, you can see the streams flowing. Where do the stream get that water? That the streams will not dry up. It means there is a storage elsewhere. And when there is a need and there is crack, that storage will sit up to fill the gap. That is another importance of groundwater. So in the course of the year, where the main source of water to the stream is lacking, we can get the rain, we can get the water from the groundwater. Now let's come to groundwater as basic resource. Groundwater as a basic groundwater as a basic resource. So in areas where people are lacking water, people can drill borehole or can drill well. So when they drill the well and they get to the water level, the amount of water will come and occupy that well, and people can get water from. So groundwater will make water available, fresh water available to mankind, even at areas where we don't have available water or reliable water. So groundwater serves as a reliable source of water to people. So when you have the money and you dig a well or you get your borehole and you connect your pipe to that borehole, at any time you can get water for both all the activities, being it agriculture, being it industrial, being it domestic use. So groundwater is one of the basic resource for mankind. That is where when you don't have water, other source of water The surface one is drying up. We don't have lake close to my settlement. That is another way by which we can get water. Let's come to uses of groundwater. What are some of the uses of groundwater? As I said, it can be used for agricultural purposes. It can be used for maybe industrial purposes. It can be used for, let's say, domestic purposes. So some too will be using the water for any other way, but some too can use for fishing, fish farming. Fish farming, they can pump the water, the groundwater, and reserve it and start the fish farming. So for aquaculture, for agriculture, that is irrigation. You can use for industrial purpose. It can be used for domestic and that of the aquaculture. These are some of the uses of groundwater. Please, any question? What of those who are using it for washing bay? So for industrial use, washing bay for under industrial. If you use it for pure water, it's industrial. But if you use it for, say, irrigation, for farming irrigation, it goes under agriculture. If you have your catfish and you want to raise your catfish, it's for aquaculture. Please, can we continue? Georgina, do you have any question? Edward, any question? All right. If there's no question, we can continue.
Hello, sir.
Hey, Edward, yeah.
Hello. Yes, sir. Please. Uh, I didn't join early. I joined it about 5 minutes ago.
Oh,
But
unfortunate.
I want to ask. I don't know whether it has already. The question I'm about to ask, I don't know whether it has already been addressed. But my
So
question
you
is,
ask.
uh, okay. So some of the groundwater, the salinity nature of it is very high. Other places to very low, and because of that,
It's
sometimes
very
using
low.
it sometimes using it becomes
For
difficult.
domestic is very difficult,
Yes,
especially
please. So I
those
want
who
to
are
know what.
close to the sea.
Yes, please. So please, may we know what causes that? Uh-huh.
Okay. Why in some areas like when you go to Accra and you construct borehole or well, we have salinity. And but when you
Yes.
go to areas far from, let's say, close to the sea, we don't have that. Is that not your question?
Yes. Yes, please.
Okay. Okay. I may say that they are being influenced by the ocean there because the amount of water that will be sitting there, that is the ocean, will percolate, will sink and into the earth. So the salinity of the ocean, when it percolates, it can be collected over there. The salty nature will be collected there. So it's because of the presence or close to the sea. Are you there?
Okay. Yes, yes, please.
All right. Okay.
Thank
Then
you, sir.
we can continue. Is that not it?
Yes, please.
Please, any other question? All right. Right. So let's move on to formation of groundwater and water table. Formation of groundwater and water table. The formation of groundwater. How, in what way, in what ways does groundwater is formed? In what way does groundwater is formed? Now, the main source of water onto the earth is through precipitation. And the precipitation can be rainfall, snow, and others. So when it rains, the water will be collected on the surface of the earth. Some will be running off in the form of erosion. Some will sink into the earth. So they'll be soaked. The water will soak the earth and drip into the earth. There are spaces within the earth, the material. So where we have spaces, and the water will take advantage of it and seep through and seep through. So when it gets down, we have something like resistant rock that will prevent the water from sinking further into the earth. So when we have that impermeable rock lying within, the water can be collected there. It can be found within the earth. The capillaries will contain the water which have been soaked or sink into the earth. But because we have hard resistant rock, that will prevent the further away of the percolation of the water into the earth. That water that are found within the earth will be trapped there. So that is how groundwater comes about. When it rains, the water will fill the earth. Some will run off. We will have stagnant water. Later, there will be evaporation. And the plants will, through their stomata and their breathing, will release some amount of water into the atmosphere through the process of transpiration. So we have evapotranspiration. Evaporation will take place on the surface. But some amount of water will sink into the earth. The impermeable rock found at the deep of the earth will prevent the percolated water from further sinking into the earth, and the water will remain within the earth. That is the underground water. So if we have the water, the structure of the earth, the structure of the earth, you group them in zones. We group them in zones. We'll have an area when the soil will be moist. So when you scoop the surface and you squeeze it, you see some amount of water found in you. That is the first, we call it zone of soil moisture. So from the top surface to about, say, 2 inches into the earth, we call that area zone of soil moisture. So when you squeeze it, you can find some amount of water in your palm. So we are going to look into the distribution of groundwater, the distribution of groundwater. So we are taking say some of the water that soaks in does not travel far because It is held by molecular attraction as the surface film on top on soil particles. This near surface zone is called zone of soil moisture. It is crisscrossed by roots, voids left by decay roots, the animals and worm burrows that enhance the infiltration of rainwater into the soil. So the zone of soil moisture, that place is from the surface to, let's say, 1 inch into the earth, or into the soil. Here, I will not use much soil. So when I say earth, I'm still using the term soil. So zone of soil moisture is a place where we can have some roots going up and down, spreading there. And we can see worms and ants burrowing into the earth. So when it rains, the rainwater will take advantage of these microorganisms' activity when they bore into the earth surface, and the water will percolate through these holes. And they are saying that it is crisscrossed by roots, void left by decay roots, and animals worm burrow that enhance infiltration of rainwater into the soil. Water is used by plants in life function and transpiration. Some water also evaporates directly back into the atmosphere. Water is not held as soil moisture percolates downward until it reaches the zone where all the open spaces in the sediment and rocks are completely filled. This is the zone of saturation. This is the zone of saturation. So when the topsoil, that is the of soil moisture, zone of soil moisture is attained, here the plant roots will take advantage. Animals, the microorganisms, the ants and others will be digging some hole into the soil. So the rainwater will sink into the earth. So the collected water here will be evaporated. The plant leaves, since through the process of the photosynthesis, the roots will make use of the water found at this region. Some of the water will transpire into the atmosphere. Are you with me? Some of the water will transpire into the atmosphere through the stomata of the plant. Some will still percolate, will sink into the next zone. Some of the water found within the earth will sink into the earth zone. And we call that zone where the water is occupying the cracks within the earth, we call it the capillary. We call water found there are known as zone of saturation. Zone of saturation. Also called the phreatic zone. The phreatic zone. Water in the zone of saturation is called groundwater. So either you call it groundwater or water, groundwater or water zone of saturation. Zone of saturation. The upper limit of this zone is known as water table. So this is the zone of saturation. Now, beneath the zone of saturation, we are going to have the groundwater. So the top here is called the water table. So when you dig borehole and it reaches here, the water will come up to occupy the empty space there at the zone of saturation. Are you with me? So here, the top where you dig and the water will begin to gush out, this zone or this line is called the water table. Please agree. It's called the water table. Please, can we continue?
Yes, sir.
All right. Swami, do you have any question? Razak, any question? James? Right, we
No, please.
continue. If there's no question, let's continue. Now, they are saying that extending upward from the water table is the capillary fringe. Here, groundwater is held by surface tension in tiny passage between grains of soil or the sediment. The area above the water table that includes the capillary fringe and the zone of soil moisture is called unsaturated zone. It's also known as vadose zone. Vadose zone. The pore space in this zone contains both air and water. So although the considerable amount of water can be present in the unsaturated zone, this water cannot be pumped by well because it clings too tightly to rocks and soil particles. So at the zone of saturation, you can squeeze the water, you see the moisture in your palm. But when you dig a hole, borehole to that level, you not get water unless you dig to reach the water table. So here, advice is that if you want to construct well or you are using borehole, you must consider the season of the year. The season of the year. When you dig a borehole at the rainy season, the water table will come up because more water can be found within the earth or the soil. So at the dry season, the water table will come up. At the dry season, because the supply of water will be reduced by the rain or the precipitation, the water table will come down. So it is advisable to dig your well at the dry season. So at the dry season, when you reach the water table, you can have water supply throughout the year. But when you do it at the rainy season, during the dry season, the water table will go down and your well will dry up. That is the advice with respect to the water table. The water table fluctuates. At the rainy season, it comes up. At the dry season, it goes down. So at the dry season, when you construct your well, you can get water throughout the year. At the rainy season, because the water table will come up, you not get enough water during the dry season. Let's come to the variations in the water table, and that is what I've said. the variations in the water table. So the upper limit of the zone of saturation is a very significant feature of the groundwater system. Knowing that water table level is important in predicting the productivity of well, explaining the chances in the flow of spring and stream, the chances in this. Edward, do you have anything to say? Your mic is on. Or mute yourself. Mute yourself if you don't have anything to say. Edward.
Okay, sir.
All right. Or do you have a question to ask?
No, please.
Okay, then we can box on. Right. So as I said, the water table fluctuates. At the period where you have enough rainfall, the water table will come up. At the area where we don't have the enough rainfall or precipitation, the water table will come down. So if you want to make available water throughout the year, through maybe construction of well or a borehole, we need to do it at the dry season where the water table has gone down. The moment you dig your well and it reaches it gets to the the water table, you can have your water supply throughout the year. Agree?
The zone of moisture in that place because if the decay plants and that of animals manage to seep into the saturated zone, is there possibility of contamination that will affect the water table?
Yeah, somebody is asking if there's possibility of contamination when, let's say, you dig a borehole close to a dumping area. Dumping area. Yes, there's a possibility because the microorganisms will mix with the water and it will go down, and it can cause that. My first place of teaching, the pump water, the hand pump water that we were using was close to a dumping refuge dump. And anytime you fetch the water, you can see that maggot and that swimming up and down in the water. So it can contaminate the water. That is why we shouldn't pollute the environment. And when you are constructing well, according to Ghana Water Company Limited, it should be distance from even where you have your toilet or your what do you call it? Manhole, 100 meters from there. 100 meters from the manhole so that you not contaminate the water. So there can be a possible contamination of water when that well is close to unhygienic environment. Good, you can do that. Now, let's come to interaction between groundwater and stream. Interaction between groundwater and stream. We get to know that in the absence of rainwater, the amount of water in the stream, though the volume can decrease, but we can get some amount of water in the stream. And we started by saying that it is because of the groundwater. So we are going to look into the reaction between groundwater and that of the stream. And it's saying that the interaction between the groundwater system and stream is a basic link in the geologic cycle. This interaction can take place in one of the three ways. So we are going to look at three ways by which the groundwater and streams can interact. The first of it is called gaining stream. Gaining stream. So it's saying that gaining stream is stream gain water from inflow of under or groundwater through stream bed, through stream bed, through stream bed. You know, stream bed. That is the valley, the ground that the water flows through. That is the stream bed. So when the stream gain water of the underground water through the stream bed, it is known as gaining stream. So for this to occur, the elevation of the water table must be higher than the level of the surface of the stream. So this should be the elevation of the bed, of the land. Let's assume this is the land and this is the stream. So the water will sip from here and enter into the bed. So if the underground water is fetching the stream with water and the surroundings tend to be higher than the stream bed, that is what is called gaining stream. Gaining stream. Let's come to what is known as losing stream. Losing stream. It's saying that streams may lose water. Streams may lose water to underground system by flowing through stream bed. The term losing stream is applied to this situation. When this happens, the elevation of the water table must be lower than the surface of the stream. So the first one, gaining stream, the elevation of the water table should be higher. If the water in the bed will be losing, it means the elevation of the water table is lower. So more will be sipped into the water table or the saturated area. Please, is that okay? That is the losing stream. It happens when the elevation of the water table is lower than the water bed. Gaining water when the elevation of the water table is higher than the stream bed. Let's go to the third possibility, how there is an interaction between groundwater and the stream. The third possibility. The third possibility is the combination of the first two. So this one, you and I were not there. Both the gaining water and losing water are working at the same time. So it's saying that the stream gain in some sections and loses in others. So losing stream can be connected to groundwater system by continuous saturated zone. So when the elevation is lower than elevation of the water level, is lower than the stream bed, it means the water is going to, or the stream is going to lose more water. On the other hand, if we have higher elevation of the water table, it means more will be connected to the stream. So when these two are in place at a certain, let's assume that at the upper course of the river, the water table is low. The stream will lose more water. When you get to the lower course of the river, and the water table here is high, the stream will get more water. You get me? So that is the losing and gaining of water acting at the same time on a stream bed. At one area, the water table is low. The river or the stream will lose more water on that same bed. And let's say at the lower course of the river, the water table is high. The stream will get more water in the bed. Agree. So that is losing and gaining streams at the same time.
Surface.
Okay. So at one point, you see the water being shallow, small. But that seems there can be, let's say, tributaries draining. So the amount can increase. But what about dry season? When the tributaries are not supplying more water, but the water table can be high at that level, and you can get a considerable amount of water on the stream bed. Agree? Okay. Now let's move on to factors influencing the storage and movement of groundwater. What are the factors that influence the storage and movement of groundwater? The first one is porosity, porous. The type of rock. Here, when I'm saying rock, please don't limit yourself to say obotanbi. No, but we have types of rocks like sedimentary rock, we have metamorphic rock, we have maybe igneous. And even the sedimentary rock, we have types of sedimentary rock. The rudiceous type of sedimentary rock, the arenaceous type of sedimentary rock, and arenaceous type of sedimentary rock. So the rudiceous are the bigger ones. The arenaceous are the small ones, like the powdered ones. The clay. So the clay doesn't have, it's compacted. So we don't have space in between. So when it flows, water is collected on the clay. Though we can see that the amount of water that are found on the surface of the soil or earth is high, but because clay is compacted, percolation will be low. But when you take a place like loamy environment or sandy environment, where we have more space, water found on that area can sink easily. So the porosity depends on the type of soil found there, especially if we have the type of sedimentary. Is it clay? Is it loamy? Is it this? Is it that? Will determine the amount of porosity found. So the water, the underground water, will depend on the type of soil or the type of sedimentary rock found there. if we are in the loamy environment, percolation will be high. If we are in the sandy environment, percolation will be high. But if we are in the clay environment, because of the continuous or the compartment is very high, we may have low percolation. So the porosity depends on the type of soil or the type of sedimentary rock found at that environment. The higher the porosity, the more percolation. The lower the porosity, that is the compartmentality of the soil is high, the porous, the sinking, the percolation will be low. That is the space by which the water can flow. Let's come to the permeability. The permeability. How the soil or the earth will allow the water to sink through. That is permeability. Some of the rocks are impermeable. Some of the rocks are permeable. So it will allow the water to pass through. For example, when we take the zone of moisture and the zone of, say, saturation, they allow the water to travel through. And that is the permeability. But where we have parent rock, hard resistant rock, sitting within the earth interior, the permeability will not be there. So where we have the loose rocks concentrated, permeability is high. Where we have hard resistant rocks and where people have cemented their compound, permeability is low. And it will amount to amount of groundwater that are found at that particular area. Please, is that okay? So the permeability and impermeability is saying that can be divided here, groundwater can be divided into two categories. The first one, the portion that percolates downward under the influence of gravity is known as specific yield. And the part that is retained as a film on particles and the rock surface and in tiny opening is known as specific retention. So here, retention can be high. The water will be collected over here. But here, the water can still percolate. So where the water can still go down, we call it a specific yield. But where the water is retained, we call it specific retention. Is that okay? So let's come to specific yield. Where do we say we can find the specific yield? Specific yield indicates how much water is actually available for use, either by plants or any organisms for use. Whereas specific retention indicates how much water remains bound in the material. Please don't think when you dig the well, we have an area where the water will be sitting, like water in the reservoir. No, they are mixed with soil or earth. But because we have permeability rock, impermeability rock sitting there, the water cannot further percolate into the earth. So where the water cannot be allowed to sink into the earth, that is where you call it retention. They are found within. So when you dig a hole, it will sip like seepage, and you see the eye dropping, the eye of the water dropping into the hole. So where the water cannot, but can go through, we allow for further sinking. We call it specific yield. Where we have impermeable rock sitting there, we call it retention. Yeah.
It means that in that process where we have impermeable one, the water will not last long. Why if you have a water and you have this amount of water in it, which you don't have this.
When you say permeable, it's allowing water to pass through. If you say impermeable, it means the water cannot pass through.
So in those that are collected from that impermeable one, provided you happen to collect them all, then you need that score.
No, it links to the other side. So it will sink. But here be a situation. Let's assume we have so many boreholes here. Boreholes. So borehole 1, we have constructed to this level. Borehole 2, it goes beyond the first one. Borehole 3 reaches here. It will get to a time. The water table coming down, the borehole 1 will lose the water in the borehole. Borehole 2 may get small amount. Borehole 3 may have enough because it has sunk. You see. So when you are able to go down, you can get bushmeat. You can get more bushmeat. You can sink more.
So, and how long does it stay?
That one I can't tell, depending upon the weather and the usability of that water. Now let's come to what is aquitard and aquifer. The aquifer and aquitard, the terms. Now, it's saying the impermeable layer that hinder or prevent water movement is known as aquitard. Retard, prevent. Clay is a good example. It will prevent further movement of the water into the soil. It will retard. That is the aquitard. On the other hand, large particles such as sand and gravel have large pore space. Therefore, the water movements through with relative ease. Permeable rock strata or sediment that transmit under groundwater freely are called aquifer. So the aquitard will prevent movement of the water. Aquifer will allow. You see the difference? Okay. Clay is an example of aquitard. So at the rainy season, you see that water can be collected at the surface, especially the hard, where we have these metamorphic rocks. You see the water being collected at the surface of the earth. That is the aquitard. But where we don't have clay, so at the rainy season, water will be collected at the surface. The place will get flooded. Aquitard. But the moment you enter into the dry season, small time, and the water is evaporated, you see cracks there. The soil pump, the pans, you see cracks there. So at the rainy season, the soil will close up, and the water will be collected at the surface of the soil.
It means that our water
will not sink, but will be evaporated. So aquifer is when water, the soil allows the water to move. Aquitard, it retides. Example is where we have maybe some metamorphic rocks, when we have clay, where we have a sand pan, like Afram Plains, sand pan. At the dry season, you see the place flooded. At the rainy season, at the dry season, the water is evaporated and there will be cracks on the surface of it. That is the difference between aquifer and aquitard. Movement of groundwater and wells, that is the Artesian system. The Artesian system. Now, this. Okay, so let's look at groundwater flow system. And you are saying that the movement of water in the atmosphere and the land system is relatively easy to visualize. But the movement of underground water, you and I cannot see. We can't see them. So they are saying that although subsurface streams do exist, they are not common, but rather, as you learn in the preceding session, groundwater exists in porous space and fractures in rock and sediment. So, flow system, groundwater flow system. Groundwater, simple groundwater flow system. And they are saying that it shows groundwater movement along flow path from recharge area where groundwater is being replenished to the discharge area along a stream where groundwater is flowing back to the surface. So discharge also occur at springs, lakes, and wet water, and in coastal areas where the water enters into, where your stream enters into is the discharge. So water can be discharged into where we have springs, streams, rivers. And then it can go, the water can enter into the ocean. So these are the possible areas by which groundwater can discharge. And we have artificial way. If we dig a well or a borehole, it can also discharge. You get it? That is why we can collect water from a well or borehole. Is that okay? So what happens? You ask how you and when we started. So listen, we are there. Your question is now going to, and I said the gravity forces. So they are saying that where groundwater is being pumped up to the surface are artificial discharge area. The force that moves groundwater is known as gravity. So the force of gravity. And I answered you that. In response to gravity, water moves from areas where the water table is high to the zone where water table is low, so that we can have balanced water. That is why Libya, which is on the desert area, we can still have water. The oasis, they are there. So if we have like osmosis, movement of water molecules from a region of higher concentration to a region of, that is also diffusion, water movement of air molecules from a region of. So if, why people would think that, okay, if underground water is being, groundwater is being supplied by rainfall, what about people living in the desert area? We have mentioned oasis, water found in lakes there. They are saying that if at the rainy season or rainy environment, like tropical rainforest, we have so much rainfall or percolation, and that place is up under the soil, they can slip into areas where we don't have enough rainfall to occupy there. That is why at the desert areas, they still have groundwater there. That is why Gaddafi was able to construct artificial stream there. Is that okay? So it moves from the region of high concentration to a region of low concentration. But the water can push up from the ground to occupy well through the force of gravity. Are you there? Can we move on? Please, any question? Augustine, do you have any question to ask?
No, sir. Please, you can continue.
You are okay with the movement?
Yes, sir.
All right. Samuel, do you have any question to ask? Kwesi? Silence means concern. They can continue. Oh, we are looking into what well and artesian system. Well and artesian system. So wells, we have all seen wells before. So the most common method of removing underground water is to use a well, a borehole, into the zone of saturation. That is where you can get water. The zone of the moisture, you can't get any water there. So wells serve as a small reservoir into which groundwater migrates and from which it can be pumped into the surface. The use of well dates back many centuries and continues to be an important method of getting water today. And through the use of well, Abraham, or no, when Isaac, Isaac was having the two sons. Isaac,
No, Jacob, brother.
Jacob. No, Abraham. Abraham married. No. We are talking about well. Through well, Isaac got a wife, Rebecca, because she was fetching the water from the well. Uh-huh. So from the ancient time, there was well from the well. Through well, somebody got husband. Okay, the Zamzam well. So well is as old as Adam. So let's continue. So underground groundwater is the principal source of drinking water for about most people in Ghana, more especially at the areas where we have these surface mining and all our water bodies have been destroyed. We rely on groundwater for our domestic and other activities. Some even use it in production of it's true. And so all that we need to do is that if you want to construct well, we do it at the dry season. The reason is that at the dry season, the water table will drop down. So when you construct and you reach the water table and the water begin to flow, you can get water throughout the year. This effect saying that therefore to ensure continuous supply of water, a well must penetrate below the water table. Whenever substantial water is withdrawn from a well, the water table around the well may be lowered. This effect termed draw down. The term draw down. That is when we withdraw water from the well and get to the water below the water table. Decreases with increasing distance from the well. The result is a depression in the water table, roughly conical in shape, known as cone of depression, because the cone of depression increases the hydraulic gradient near the well. Groundwater will flow more rapidly towards the opening. For most small domestic well, the cone of depression is negligible, it's very small. However, when well is heavily pumped for irrigation or industrial purpose, the withdrawal of water can be great enough to create a very wide and steep cone of depression. This may substantially lower the water table and the area in an area and cause nearby shallow well to be dry. This has been the case for many years in Ghana, where certain companies use dug out well to produce in their production, where they draw large quantity of water from the water table. And this is true. This is true. We have In our area where we stay, at my village, there's two houses close to our area. The two house owners have constructed well, one at our left here, one at our right. And I've also constructed borehole, the drill one, and I'm using it for small pure water, organ pure water, organ waters. So at the dry season, when I pump my water into my polytanks for production, the people were complaining that I've caused their well not getting water. And I told them, I'm a geographer. I constructed my borehole at the dry season. So if you like, at the dry season, so this is what I'm saying. When somebody constructs the well to this side, somebody too has constructed the well to this side, and we are all struggling for available water, and somebody has penetrated inside. You reach inside and you get into inside, this person can get more water. And this one, you get it, getting into inside. You get more water inside than the shallow one. Is that not it? So sometimes if the top is dry, deep inside, you get water there. Okay, so let's continue with the
What are you thinking?
bad boy. Artesian system. What is the meaning of artesian? So my advice is that future prospective business people, producers, if you are producing any product and water can be your main source of the production, make sure you construct your well at the dry season and make sure that it goes into some level before you allow the person, the operator, to leave. What is artesian systems? Saying that in most wells, water cannot rise without the use of pump. Like the borehole, water cannot come up. It will get to a certain level and you can't reach. So water cannot be used without pump. If water is first encountered with the depth of say 30 meters or 100 feet, it remains at a level fluctuating perhaps 1 to 2 meters with seasonal wet and dry period. However, in some wells, water rises, sometimes overflow at the surface. Such wells are abundant in the Artios region of northern France. Such wells are called, these self-rising wells, artesian wells. So they can come out at a certain level and it be there, but at a certain level it will flow out. That is the artesian well. This one is not artificial, it's natural one. So the term artesian is applied to any situation in which groundwater under pressure rises above the level of the aquifer. For the artesian system to exist, there should be two conditions to meet. One, water is confined in an aquifer that is inclined so that one end can receive the water. Two, aquitard. Both above and below the aquifer must be present to prevent the water from escaping. So if we are going to have the artesian water coming up, these two, now we know what is the aquifer and aquitard. It should work hand in hand. Where one will be allowing the water to flow, the other side, the water should be seized from movement so that the gravity can pull the water up and they can flow. Can we move on? Then it's saying that such an aquifer is called confined aquifer, concentrated water found in an area. When such a layer is tapped, the pressure created by the weight of the water above which force the water to rise. If there were no friction, the water in the well will rise to a level of the water at the top of the aquifer. However, friction reduces the height of the pressure surface. The greater distance from the recharge area where the water enters the inclined aquifer, the greater the friction and less water is rising. Not all artesian systems are well. Okay? So wells can be artesian, but not all wells or no artesians are well. So when you go to France, they have what is called artesian spring. Because one area will be aquitard, one area will be aquifer. That is movement of the water will be here. There will be no movement of the water at the other side. So when there's pressure, water is collected and there's high gravity, the water will come out and flow out. And we call it artesian spring. Artesian spring. Artesian spring. So let's look at what is the meaning of artesian spring. Artesian spring may also result when underground, that is when groundwater reach the surface by rising along the natural fracture, such as faults, rather than through artificial produced holes. You get me? So when we use the borehole, we have destroyed the fracture, the structure of the earth. That is why water is collected. But what about the natural way? So the natural way, there can be cracks within the earth interior, and the cracks will happen at where the water can be collected from. So the crack happen will let the reservoir of this water, that is underground reservoir. If we have cracks here, a crack is here, this underground reservoir, and the crack is here. The water will take advantage of the fracture or the crack, and it will sit up and flow like spring. That is why we call it artesian spring. They have springs, but they will give credit to the advanced countries because you're not the one who studied it. Of France. Artesian springs are sometimes responsible for creating oases. Please, oases are the springs that can be found at the desert areas. Oases are, let's say, wells that are found at the dry or desert areas. So artesian system act as a conduit, often transmitting water greater distance from remote areas of reaching to a point of discharge. That is why I'm saying that. I said that at the desert areas where Muammar Gaddafi was able to create an artificial stream linking their major towns so that they can use for commercial and industrial activities. That's the artesian springs. Please, any questions so far? Any questions so far? Any questions so far? James, do you have any question to ask?
Oh, I'm good, thank you. We can continue.
Yeah, you are with me. Okay. Stephen, any question?
No, sir.
You are okay with us. Okay. Then we can move on. We can move on to springs, hot springs, gases, and environmental problems. What is the meaning of springs? How does a spring or a stream, which is supposed to have a minimum temperature, say, that people can drink, but that spring has become hot to a point that even if you put an egg into that spring, it can boil. You collect it at 10 minutes, the egg is boiled. How come that hot spring? And the environmental challenges associated. So let's take what is termed as spring. So as I said, a spring can come when we have an aquifer and saturated area, or the aquifer and aquitide. And if we have the balanced way from the higher concentrated to the lower concentrated, there can be a spring flowing. But then naturally, there should be crack or fracture within the earth or under the earth surface. So sources of springs. Sources of springs. Springs. Now, somebody will ask the difference between a stream and a spring. The spring are the tiny water body flowing on the surface of the earth, the tiny one. So the spring will flow into a stream. The stream will flow into a river. So the tiniest flow of a river, flow of water found on the surface of the earth is known as the spring. So the source of springs is water from the zone of saturation. And that's the ultimate source of this water is precipitation. The ultimate source of spring water is through precipitation. Can be rainfall, It can be snow, and so on and so forth. Whenever the water table intersects with Earth's surface, a natural outflow of groundwater results, and this is called a spring. So there has been storage of water here, and there is, say, crack or fracture here. The water would take advantage of it, the stored water, because there's gravitational pull, pulling it up, rising it up. The water was sipped up. So it's like the weight of the earth have been removed, and it will push the water found underground to come out, and it serve as a spring. So springs often form when an aqueduct blocks the downward movement of underground or groundwater and causes the water to move laterally. Where the permeable bed rocks, the bed crops up, a spring results. Springs, however, are not confined to places where patched water table creates a flow at the surface. Many geologic situations lead to the formation of springs because subsurface conditions vary greatly from one place to another. Even in areas underlined by impermeable crystalline rock, permeable zone may exist in the form of fractures or soluble channels. If these openings fill with water and intersect the groundwater along the slope, spring results. So there should be impermeable rock there, and there should be permeable rocks. That water can be collected at their capillaries. So when there is, let's say, crack, the water found at the permeable rock would take advantage of the cracks and seep out. So when there's a seeping out of the water from the permeable rock, then we are saying spring have been formed. The main source is the true precipitation. Agree. Agree. Stephen, agree. Stephen, do you get me? Agree? Okay. Augustine, do you have any question to ask?
No, sir.
We can continue.
Yes, sir, please.
Okay. Hot springs.
Stop from rainfall.
Spring is found underground. The rain will fall and get percolation and stored here. Let's take it from here. This the moisture. This area is the zone of saturation, and we have our water table here, and water can be collected. Here, no, we have sand mixed with sand and soil, but it's more moist under here. Do you get me? So this is our impermeable rock, unsaturated material is here. It has prevented this percolated water from further sinking to this side. So now the water has been collected here at the top here. There has been a crack, and I will not use crack, but I will say fracture within the earth. Okay, so when there's fracture within the earth, the water collected here will flow out. A form assassin will flow out. So be who say nsuo no wakɔ baabi a nsuo ɛhyɛ aseɛ n'ani no na ɛba. There's a crack like tube coming out. That's where we say spring had been formed. You get me? You get me? Now, what is hot spring? So the spring, the temperature is normal. You can drink with ease. But sometimes there can be a situation where the water is flowing. The temperature will change. And instead of normal cool water, it not be normal cool water. You can even fetch it, put your Milo into it, stir it, near here in Susia. Then Susia also the unya saya na then you drink. So that is hot spring. So what is hot spring? So we don't have investor accepted. But when the temperature is, you feel the temperature, the thing is warm. That is the hot spring. So it's, let's say, warmer than the normal water that, even when the water in the container, because of the temperature, we say in soy ice. Is that nothing? In soy the ice is returned to in soy ice, meaning that that water that is warm is warmer than the normal water that we are talking about because of certain conditions. Because of certain conditions. So how does hot spring happen? So it's saying that the water in the hot spring is between 6 degrees to 9 degrees Celsius, warmer than the mean annual air temperature for the locality where it occurs. In the United States alone, there are more than 1,000 such springs. Temperature in deep mines and oil wells usually rise with increasing depth, and an average of about 25 degrees Celsius. Average of about 25 degrees Celsius per kilometer. That is the geothermal gradient. Therefore, when groundwater circulates at great depth, it becomes heated. If the hot water rises rapidly to the surface, it may emerge as hot spring. So we have something like deep here. And the more you are traveling into the earth interior, the hotter the temperature is. So let's assume the water has been collected here, and the temperature is warm within or beneath the earth. Beneath the earth, the temperature is warm, and water is collected here. So when this water, which is warm within the earth, gas out, the water temperature will be warmer than the normal one, which is flowing. That is the hot springs. How hot springs occur. Now, geyser or geysers. The difference between, there's a slight difference between geyser and hot spring. but in some areas, they are the same. So let's assume in the volcanic eruption. So we have volcanic activity happen. Let's assume when we say volcanic activity, we are talking about when magma flow, it comes up. Sometimes the heat of the magma will be left there. So when the spring is flowing and it passes at where the dormant volcanic activity is happened there, the heat there will change the temperature of the water. And when it comes out, we call it geyser. So the hot spring will happen when maybe we have deep hole deep into the earth. Are you there? A hole deep into the earth interior. And if the water can be collected there, and there is a seepage coming out, you can have the water being warmer. But the geyser will happen when there is a volcanic activity, and the hole which will be left there, there will be still heat coming up. So when the water flows at that area, the temperature will change, and you get we call it geyser. So where we have more springs happen at where volcanic or magma had been thrown some years ago, we call it geysers. The single or the singular one is the geyser. Are you there? So the difference between a spring, hot spring, and geyser is that geyser will happen at where we have volcanic activity. That has happened. But the spring, where the temperature, if we have deep cool and the water has been collected and that water gush out, that is the hot spring. Now you know the difference between geysers and hot spring. Hot spring will happen at where we have volcanic, or the volcanic is when the magma comes out. When it settles within, we call it magma. Okay. When the fluid settles within the Earth's interior, we call it magma. When it comes out, we call it lava or volcanic activity. So when the magma or the lava activity happens, then we have the geyser. When it's as a result of maybe cool into the earth, and the temperature at that place tends to be high, and the water comes out, we call it hot springs. Please, are you there? Are you there? Okay, so let's read. Geysers. Geysers are intermittent hot springs or fountains in which columns of water are ejected with great force at various intervals. But when it comes to the difference between geysers, they will tell you geysers in the United States are found in the West. This is because the heat source for most hot springs are magma bodies and hot igneous rocks. So geysers are formed as a result of the activity of volcanic eruption, volcanic activity or the magma activity. And they are saying that geysers are intermittent hot spring or fountains in which columns of water are ejected with great force at various intervals, often rising 30 to 60 meters in the air. So it will spring like that, but it's very cold. After the jet of water ceases, a column or stream rush out, usually with the tendrils roar. Perhaps the most famous geyser in the world is Old Faithful in Yellowstone National Park. How geysers work, I've already told you how geysers work. Geysers occur when extensive underground chamber exists with hot igneous rock. As relatively cool groundwater enters this chamber, it is heated by the surrounding rocks. At the bottom of the chambers, the water is under great pressure because of the weight of the underlying water. This great pressure prevents the water from boiling at the normal surface temperature of 100 degrees Celsius. The heating causes the water to expand. As a result, water is forced out at the surface. This loss of water reduces the pressure at the remaining water in the chamber, which lowers the boiling point. The portion of the water deep within the chamber quickly turns to stream. The geyser erupts. Following eruption, cooling groundwater again seep into the chamber, and the cycle continues. So this is the chamber of the, let's say this is the chamber of the igneous rock. It's very cold. The rocks here are very cold. So when the stream, this underground water seep into this place, it will change the temperature. So the temperature here, when it continues sipping now, you get the outlet being very warmer than when the water what hasn't entered into the chamber of the igneous rock. Geyser deposits. Geyser deposits. Geyser deposits. When when the groundwater from hot springs and geysers flow out at the surface, material in solution is often precipitated, producing an accumulation of chemical sedimentary rock. You know, the sedimentary rock, we have physically or mechanically, we have or organically or biological, then we have the chemical one, like salts. So gases normally end up in getting the chemical one, like salt one. The material deposited at any given place commonly reflect the chemical makeup of the rock through which the water circulated. When the water contains dissolved silica, a material called siliceous sinter or geyserite is deposited around the spring. So it will be like something like salt around the spring. When the water contains dissolved calcium carbonate, and form limestone called travertine or calcareous tufa is deposited. The latter term is used if materials are spongy and porous. The deposit at Mammoth Hot Gases in Yellowstone National Park is more spectacular than others. As the hot water flows up through series of channels and then out of the surface, the reduced pressure allows carbon dioxide to separate the escape from the water. The loss of the carbon dioxide causes the water to become supersaturated with calcium carbonate, then turn precipitates. In addition to the containing dissolved silica and calcium carbonate, some hot springs contain sulfur, which gives water a poor taste and unpleasant odor. This undoubtedly the cause of rotten egg spring, Nevada. So the geyser, you know that the volcanic activity can cause can cause ash. You know, cocoa pot. When you burn it, you can get something like acid or alkaline in the form of salt. So when the gases come out and it contains some silica, I've never seen silica before. I'm not a science student, so I've never seen a silica before. Or calcium like salt nature. It will deposit and you get something like calcium there. When it gets rotten, it will give bad scent, that is odor, to the spring. So the water will flow. It will be the taste will be like salt, and it will give you bad odor. It's like when you go to the villages and you have stagnant water at the forested area. The plants will, the leaves will rotten into the water, and it will give you bad odor and or the bad scent, and the taste will also be changed. That is what is happening there. So when you go to one day, when you go to USA and you get to Nevada, go and see rotten egg spring. When you travel to USA, and by the grace of God, all of you will go, you go enjoy life and come. When you come and meet me, get my number and send Momo. Go to go and see the Yellowstone spring there at the Yellowstone National Park. Old Faithful in Yellowstone National Park. So when you come back, you come and tell me, Sir George, I've gone there to see the Yellowstone. Have a look at rotten egg spring. Have a taste of it. It's like bad odor. And even now, if you want to go to those who are struggling to go to the World Cup, that man says unless you get you pay your accommodation there before Donald Trump can grant you visa, how much more excursion there? Let's come to environmental problems associated with underground water. So we are coming to where we have, let's say, refuse dam. The water there will be polluted. So you see the water as underground water, yet it will be polluted. So most of the times, underground water is affected. Mining areas, underground water. So if you don't treat it well, it will affect you. That's why most people are having these the malaria, you understand, or typhoid. Typhoid. If you don't treat underground water well, We have a well in our environment there. When it rains heavily and the river there, River Brim, gets dirty, the well there too is dirty. So let's look at the environmental problems associated with underground water. Maybe we can use 10 minutes to go through this. One, groundwater depletion. We are supposed to have equilibrium water system, groundwater, but people will over pump it out. So if you don't have enough rainfall to maintain its equilibrium, the groundwater can go down. So groundwater depletion. So many natural systems tend to be established a condition of equilibrium. Groundwater system is not exception. So the water table height reflects the balance between the rate of recharge and the rate of discharge and withdrawal. So any withdrawal that exceeds the amount that will come into the chamber will have imbalance. So it will deplete the amount of water found in the container will be reduced. That is one. Number two is the subsidence. And what is the meaning of the subsidence? Saying surface subsidence can result from natural processes resulting to groundwater. However, the ground may also sink when water is pumped from well faster than the natural recharge process can replace them. So when we pump more water than the natural one balancing it, it can have the subsidence, meaning that this one can have, those over there cannot take. Then we have salt water intrusion. Salt water intrusion. If we have salty environment, like somebody asked of if the why those are the coastline areas are having salty water. If the environment is salty, it can affect the water. Though you see it as fresh, it's still salty because of the environment in which the well is found itself. And you have solution of salt water that is also there. And then you have groundwater contamination. Groundwater contamination. So if the area is close to, let's say, dumping place, refuse dump, or is close to septic tank, natural septic tank, or toilets, the toilet, the seepage will enter. That is why I started by saying that if you want to produce pure water, the water company or the environmental protection agency is always the distance should be 100 meters apart, so that if there's going to be any seepage, it will not affect the source of water. We have contamination. That, and I told you where I have my first teaching, people teacher, after my first certificate. I encountered the borehole, the hard, the one we use our identity, is close to the border. And anytime you fetch the water, you see that small organisms dance up and down. And if you don't boil it and you bath, you have that skin itching. It means water can, groundwater can be. And areas where people are using more fertilizer and weedicide in their farming activities, you get into the soil and there some rainfall, continuous percolation can let us have these fertilizer effects, pesticide and other chemicals effects. Now you can have a solution to groundwater contamination. How do we solve it? We should filtrate it, proper filtration. So you need to filtrate it, you need to boil it and filtrate it. You get your pure water to use. On this note, I'll pause here for questions to ask and to receive questions from you. Any question so far? Any questions so far? Abella. Abella, is there any question?
Sir,
Yes.
please, I don't have any question.
Hello.
Hello, sir.
Abella, I say you don't have any question.
Yes, please.
Okay, then thank you.
You're welcome,
Samuel
sir.
Kwesi,
Thank you,
is there any question to ask? Okay, if there's no question. On this note, we bring our lesson to an end and we continue next week. Continue to enjoy your lessons and have a fruitful day. Good morning.
Thank you, sir. Good morning.
Thank you, sir.
We have another lecture.